Alright, let's solve the rational equation. Negative x over x minus 1 is equal to negative 3 over x plus 7. So if we want to solve a rational equation, what we need to do is we need to find a lowest common denominator. So the lowest common denominator here is as simple as just multiplying the two denominators together, x minus 1 times x plus 7. So you want to make equivalent fractions where the denominator matches the lowest common denominator. So I'm going to multiply the rational expression on the left by x plus 7 to the numerator and denominator to create an equivalent expression, right? So you have negative x times x plus 7 over x minus 1 times x plus 7, right? If I expand this, you get negative x squared minus 7x. Now you don't need to expand the denominator. You can just keep it as x minus 1, x plus 7. I'm going to do the same thing for the next expression on the right. So you have negative 3x plus 7, and multiply this by x minus 1 over x minus 1. So this is going to give us negative 3x minus 1 over x plus 7 times x minus 1. And if you expand the numerator, you get negative 3x plus 3 over x plus 7, x minus 1. And now that you have the two numerators, now that you have the two denominators that are the same, what you want to do is equate the two, so you get negative x squared minus 7x over x minus 1 times x plus 7 is equal to negative 3x plus 3, x plus 7 times x minus 1. And once the two denominators are the same, I'm going to equate the numerators, so you can just work with the numerators right now. So you get negative x squared minus 7x. I'm just going to work with the numerators. Negative x squared minus 7x is equal to negative 3x plus 3. And you want to solve the rational equation. So in order to solve an equation, you can see that this is a quadratic. You need to make sure that the quadratic equation in the form of ax squared plus bx plus c is equal to 0. So I'm going to move all the terms to the side on the left. You get x squared, negative x squared minus 7x is equal to negative 3x. Whoops, I forgot to move all of these. Negative x squared minus 7x plus 3x minus 3 is equal to 0. So you switch the signs because I'm moving it to the other side. And I'm going to collect all the like terms. So you get negative x squared minus 4x minus 3 is equal to 0. And you want two numbers. So a here is negative 1, b here is negative 4, c here is negative 3. You want two numbers that multiply to ac, which is 3, that add up to negative 4. A quick way to do that is you could do negative x squared minus 3x minus x minus 3 is equal to 0. Negative x plus 3 minus 1x plus 3 is equal to 0. And then you get negative x minus 1 times x plus 3 is equal to 0. And then you can solve for the value of x that will make each factor 0. So you can just do this really quickly by letting each factor equal 0. Right, so x can be, so negative x is equal to 1, then x can be equal to negative 1. So this is one of our solutions. The other solution here is x plus 3 is equal to 0, x is equal to negative 3. That's the second solution, right? So both of these solutions will solve this rational equation. And we need to also write down restrictions because we can understand that x cannot equal 1 or negative 7. Because in that sense, both of these cases would be undefined, right? So it's not just enough to write the answers, but we also need to write down the restriction. So this is how we can kind of fully solve a rational equation. All right, let's look at solving a rational equation. So in order to solve a rational equation, what you need to do is you need to make sure that the denominators of the two expressions in the equation are equal, right? So let's find the lowest common denominator here. So the lowest common denominator, it's as simple as just multiplying the two together. So you have x minus 12 times x plus 3, right? So what I'm going to do here is I'm going to take this first expression on the left here, I'm going to multiply this by x plus 3, right? So I'm just basically creating an equivalent expression, equivalent fraction, right? So you get 2x times x plus 3 over x minus 12 times x plus 3. Right? If I'm going to expand the numerator out, you don't need to worry about expanding the denominator. You get 2x squared plus 6x. If I expand it out that way, you get x minus 12 times x plus 3. I'm going to do the same thing for the expression on the right. You get negative 2 over x plus 3. I'm going to multiply this by x minus 12. Right, so that for the numerator and denominator, you get negative 2x minus 12 over x plus 3 times x minus 12. And then what you can do, because you have, if I expand this out, you get negative 2x plus 24 over x plus 3 times x minus 12. So now what I'm going to do is I'm going to plug this back into the function. So we get 2x squared plus 6x over x minus 12, x plus 3. And because this is the same denominator, I'm going to just make it one full denominator, right? It's a broad denominator for the two. And you get this is equal to 2x plus 24. Now, in order for us to solve for x, right, this is basically an expression that looks like ax squared plus bx plus c. You have to let one side equal 0. So what I'm going to do is I'm going to move these two terms to the other side. So you get 2x squared plus 6x plus 2x minus 24 is equal to 0. And if I collect the like terms, plus 8x minus 24 is equal to 0. I only have to work with the numerator, right? And in this case, if you look at solving for this, you can actually notice that there's a 2 here. So you get x squared plus 4x minus 12 is equal to 0. You need two numbers that add up to 4 that multiply negative 12. So you can factor out a 6x, 2x. Right? So those are going to be your values or integers. And we get x plus 6 minus 2x plus 6. Right? And so I'm factoring this by decomposition. In this case, you get 2 times x minus 2 times x plus 6, right? So if you guys are a little rusty on this, I would really recommend you guys to go back and check out some of my factoring videos, specifically factoring trinomials in the form of ax squared plus bx plus c. And in this case, you can see that therefore, right, x can be equal to 2 or negative 6. These are values of x that will make each of these factors 0, right? And we need to also understand that there is a restriction, right? There's a restriction on the denominator of x minus 12 and x plus 3, right? And that restriction we need to write down, because if x is equal to 12, then the denominator would be 0, and that's undefined. And it's the same idea with negative 3. So it's important to also write down our restrictions as well as our solutions to this rational equation. And that's how you can basically solve these rational equations just by basic algebra, right? So expanding, factoring, finding a common denominator, and then, solving. All right, let's take a look at an application of rational functions. So the Greek mathematician Pythagoras is credited with the discovery of the golden rectangle. This is considered to be the rectangle with the dimensions that are the most visually appealing. In a golden rectangle, the length and width are related by the proportion L over W is equal to W over L minus W. A billboard with a length of 15 meters is going to be built. What must its width be to form a golden rectangle? Okay, so we can understand that if you want to calculate for length, right? Sorry, if you want to calculate for its width, we have to use this golden rectangle equation. L over W is equal to W L minus W. And we know that the length here is 15 meters, so this is going to be 15 over W is equal to W 15 minus W. And if you want to solve for this rational equation, what we need to do here is we need to make sure that the denominator is the same, right? So to find the denominator as the same, the lowest common denominator here is, we can just quickly figure that out by just multiplying the two denominators together. So we have W minus times 15 minus W. So in this case, I'm going to multiply this by 15 minus W for the numerator and denominator. So you have 15 times 15 minus W over W times 15 minus W, right? And we can expand this guy out. So if we wanted to expand this out, we have 15 times 15, which is 225 minus 15w, right? And then for the fraction on the right, w divided by 15 minus w, I'm going to multiply this guy by w, right? So we get w squared over w times 15 minus w, right? So now we've created equivalent fractions or equivalent rational expressions, right? So now what we can do here is we can equate these two equations together, right? So 15 over w we're going to write as 225 minus 15w over w times 15 minus w is equal to w squared w times 15 minus w. And once we've written down the equivalent expressions, we can understand that the restrictions on the denominator here, w cannot equal 0 or 15, right? So it's because then the function will be undefined. And then the only thing we have to really look at now is we have to look at the numerator. So we're basically just addressing this portion here, right? So now we can see that w squared is equal to 225 minus 15w. And in order for me to solve this quadratic expression, w squared plus 15w minus 225 is equal to 0. Okay? And now that we have this, what we want to do is ask ourselves, is this factorable, right? So let's think about two integers that will multiply to negative 225 that add up to 15. Okay, so you can also use quadratic formula for this, right? This is solvable. We can test this by the discriminant method, b squared minus 4ac. And if we do this, we get 15 squared minus 4 times 1 times negative 225. So you can see that this is definitely greater than 0, right? So let's postulate some values. But just to save some time here, I'm just going to use the quadratic formula. So this actually came out to be 225 plus 4 times 225, which was 1,125, right? So x is equal to negative b plus minus b squared minus 4ac. You can only use the quadratic formula if the quadratic trinomial is set to 0, right? So this is over 2a. So we already calculated for the b squared minus 4ac term. That's where the discriminant actually comes from. Negative b here is negative 15 plus minus square root of 1,125 times 2 times a in this case is 1. Now you got to note that width has to be, it's a dimension, so it has to be greater or equal to 0. Ideally we want to make it greater than 0 because we don't, 0 width means, we don't even have a width. Right, so let's assume that width here is actually greater than 0. Okay, so width is greater than 0. X, or width in this case, negative 15 plus minus. I'm just gonna rewrite width here because in our case, an independent variable is w. Right, square root of 1,125 is 33.541. So negative 15 plus minus 33.541 over 2, and ideally you want to just only look at the positive value. Width is equal to 15, negative 15 plus 33.541 over 2, and in this case we calculate this guy out. 33.541 minus 15, divide this by 2, and we get 9.27 approximately. Okay, so therefore the width can be approximately equal to 9.27, and the units here we were using meters, so 9.27 meters. Okay, so although we don't get an exact value, we can approximate it, but that's really the idea of how to solve for. Alright, let's take a look at an application of rational functions. The concentration of a toxic chemical in a spring-fed lake is given by the equation C of x is equal to 50x over x squared plus 3x plus 6, where C is given in grams per liter and x is the time in days. Determine when the concentration of the chemical is 6.16 grams per liter. Okay, so C of x is the concentration, so I'm going to let C of x equal 6.16 grams per liter, right? Because C is given in grams per liter. And we got to solve for this. So 50x over x squared plus 3x plus 6 is equal to 6.16. Now what you want to do here is let's cross multiply, or basically you're going to multiply this by x squared plus 3x plus 6, and you do the same thing here, x squared plus 3x plus 6 to both sides, cancels out. So 50x is equal to 6.16 times x squared plus 3x plus 6, right? And in this case, I want to expand this guy out, right? So you get 6.16x squared plus, I'm just going to multiply that out, so 6.16 times 3, so that's 18.48x plus 6.16 times 6, which is 36.96, is equal to 50x. And now what I want to do here is I want to solve this quadratic equation, because it is an x squared, right? It's in the form of ax squared plus bx plus c, and I want to set this equal to 0 to solve it, right? So I'm going to move the 50 to the other side. You get 6.16x squared plus 18.48x minus 50x plus 36.96. So you can already kind of see here that we don't have we aren't able to factor these this equation, so we're gonna have to use quadratic formula. So this is 6.16x squared. I'm going to subtract these two, so 18.48 minus 50. So we get negative 31.52x plus 36.96 is equal to 0. And then what I'm going to do here is I'm going to use quadratic formula. So x is equal to negative b plus minus b squared minus 4ac over 2a, right? So if I'm solving for this, negative b here is 31.52 plus minus b squared is basically 31.52 squared, so negative 31.52 squared minus 4 times a here is 6.16 times c here is 36.96. I'm going to divide this whole thing here by 2 times a, which is 2 times 6.16. Okay, so I'm going to solve for that. So if I solve for this, so x is going to be equal to, if I clean this up, 31.25 plus minus 82.816 over 2 times 6.16, which is 12.32. Okay. Now, you want to figure out, so x is time in days, so we know that x has to be greater or equal to 0. We can't have a negative number of days, that makes no sense. Right, so let's figure out what these two values are. So if I plug this in, I'm just going to round my answers to 2 decimal places, guys. Right, so depends on what your teacher wants you guys to do, but because the question has 2 decimal places, it makes sense for me to round it to 2 decimal places, right? Divided by 12.32, so x is equal to 3.275, so I'm just going to round that to 3.28 days. That's one of my solutions. The other solution here, x is equal to 31.25 minus square root of 82.816, and then this is divided by 12.32. So I got x is also equal to 1.7978, so this is approximately 1.80 days. So this concentration will reach 6.16 at 1.8 days and 3.28 days, right? So it's going to hit that twice, right? So both of these answers are effective, right? And that's really the idea behind it, right? So you can have 1.80 days or